Good morning, guys. Anjani Kumar here, dealing instrumentation subject for a final year electrical students. Right. In the last session, we started a strain gauge, and we discussed about some definition, right? So I just want to give a brief glimpse of that all the things that what we discussed in the last session, right? So we discussed about what is a stress. Stress is nothing but force per unit area of a material. So what is a stress? Force by area. And what is a strain? Strain is nothing but extension of a material per unit length. So what is an extension? We can call it as a delta L by L. We can call it as a strain. Right. After that, we discussed about the working principle of a strain gauge. You know that the strain gauge is nothing but a resistive transducer, right? So how it will work means, when a metal conductor which is stretched or compressed, the resistance of that material will change. So while measuring the changing resistance with the help of Wheatstone bridge or any other instruments, so whatever the voltage that you are getting, which is analogous to the applied stress, so that way we can find the stress, force, strain, compressed, and all these things that we find. Right. So this is a systematic arrangement of a strain gauge. It is nothing but a metal conductor. When force is applied, definitely the resistance will change. So when a resistance will be changed, that can be applied to the Wheatstone bridge. The bridge doesn't go for a balanced condition, and it will shows the voltages, how the voltages came by changing the resistance, how the changing resistance came by applying the force. That means whatever the force that you applied, that is equal to the voltage that you are getting. Right. So up to these things that we finished in the last session, right? In today's session, we discussed about how the resistance will change. Right? See. So we have a metal conductor cross-section area is like this. Right? So this is the length of the conductor, right? So this we can call it as a diameter, right? If you are applying the force, it should be a stretch or a strain, stress, whatever it may be, that force that you applied, right? Now we'll see. So definitely what happened, so conductor should be stretched. So this we can call it as a length of a original conductor, and actually this is a diameter, but the change in diameter we can call it as a delta D, right? So this is the force that you applied, right? So this we can call it as a change in length, right? So when you apply a stress on the conductor, what are the factors that are changing? The length of the conductor will change, length of the conductor will change, and the second one is the diameter will change, right? And the third one is area will change, right? The fourth one is resistivity will change. Right? So the change in length, so we can call it as a delta L. Right? So diameter we can call it as a delta D. Area we can call it as a delta A. Resistivity we can call it as a delta rho. So we can call it as a delta rho. You know that these are the parameters changes. Means what is the formula for resistance? You know that resistance is equal to rho L by A. Correct? If your resistivity changes, your length changes, and your cross-sectional area changes, what about the resistance? The resistance also changes. Now when you applied a force like a stress or a strain, compressed or a stretch, so definitely what are the things that you are changing? Your length of the conductor changes, your diameter of the conductor changes, and the area will changes, and the resistivity of the material will change. So how these factors changes means your resistivity changes, your length changes, your area changes. According to that, your resistance will changes. Alright, so your resistance changes means whatever the force that you applied, the resistance will changes. So how your resistance change in resistance you can find out with the help of the Wheatstone bridge. So the Wheatstone bridge will show the voltage, null deflection voltages, right? The bridge doesn't balance. Why? Because the change in resistance you are applying. So according to the change in resistance, your bridge null deflection will show some value of voltage. So how the voltage came? By applying the changing resistance, right? How the changing resistance came? When applying a strain. So what about the strain, which is analogous to the voltage that you applied, right? So this is a working principle of a strain gauge. See, now we are going to discuss about important term called gauge factor. It's very important concept. Gauge factor. So if you want to measure the change in resistance in a strain gauge, first you have to know gauge factor. So then only you can identify how much resistance will change. So gauge factor is nothing but the sensitivity of the metal. So it can be defined as the ratio of change in resistance by to change in length ratio, right? So what is a gauge factor? So you can denote it by gauge factor is equal to change in resistance, original resistance by change in resistance by original resistance, right? By change in the length, delta L by del. So this is very important bit. So if you want to measure the change in resistance, first you have to find out the gauge factor of the strain gauge. So it will show the sensitivity of the material, right? So what is the sensitivity? What is your output? Delta R by R. Resistance is changing. What is the input? The length is varying. Like a sensitivity, right? So what is a gauge factor? Also we can write it as, so delta R by R. So what is delta L by L? Extension per unit length. We can call it as a stress, right? So from this you can calculate the stress also. Stress is equal to gauge factor into delta R by R. These two formulas are very important, right? So what is a gauge factor? It is the ratio of change in the resistance by the change in the length. So in order to find the change in resistance, first you have to find out the gauge factor in your strain gauge, right? It will give the sensitivity of the material that you are using, right? So if the gauge factor is increases, means that much sensitivity of the material that you are using in your strain gauge, right? What is the gauge factor? Delta R by delta L by L. Alright, so what is delta L by L? We can call it as extension per unit length. We can call it as a stress that we discussed in a last session. right? How you can write it as gauge factor is equal to delta R by stress. So if you know the gauge factor, you can easily find out the stress value. So stress is nothing but gauge factor into delta R by R. I hope it's clear. Alright, now we will solve the equation for a gauge factor. This is very important in your end examination. Alright, try to follow. See, derivation. Gauge factor. I'll write it here. What is a gauge factor? Delta R by R by delta L by L. Alright. So first you have to know what is R value. Rho L by E. So what are it? So rho is nothing but resistivity. L is nothing but length. A is nothing but cross-sectional area. Hope it's clear, right? Now you are finding first, if you want to define a gauge factor, first you have to know what is delta R by R. Right? First, delta R is nothing but a differentiation, right? The differentiation of R, so dr. Alright, so the first differentiation for length, rho by a constant. So what is the length? TL. Alright, TL. So differentiation with respect to whatever the input that you applied, stress. Alright, so dr by ds. First L తీసుకుంటున్నాం. So rho by a constant. So L is also L is in terms of L that I am calculating. So dl by ds. Next we'll go for A. A is nothing but 1 by A. So what is the differentiation of 1 by A? Minus 1 by A square. Alright, so that means minus, you put rho L is a constant, right? So by A square dA by ds. Alright, next and rho. So what is that rho value? L by A constant, right? So dou rho by dou s. Any doubts? Right, you are differentiating your resistance with respect to the strain. So dou r by dou s is equal to first L differentiation చేస్తున్నా. Rho by a constant. What is L differentiation with respect to s? dl by ds. Now 1 by a. So 1 by a means 1 by a square minus 1 by a square. Rho L is a constant by a square dA by ds. Hope it's clear. And then we'll go for resistivity. So L by A is a constant. So d rho by ds. Alright. Now another is dr over. Now it can be divided by the whole equation divided by r. So just apply 1 by r. So dr by ds. So r is nothing but rho L by A. So by rho L by A, you are applying by rho L by A. Right? By rho L by A. Right? Then you will get, so rho L by A, rho by A cancel. You will get 1 by L. So dl by ds. Here you will get 1 by A dou A by dA by ds. Right. Here you will get 1 by rho d rho by ds. Right? Any doubts up to now? Right? If you make it as 1 by r dr by ds, that means for finding your gauge factor you need to divide the equation by r. So that's why I did 1 by r dr by ds. if you make this one, you will get 1 by L dl by ds minus 1 by A d by ds dA by ds plus 1 by rho d rho by ds. Right? Now you know the value of, now I just want to write it here. You know the value, we know the cross sectional area of a conductor. So whatever the conductor you are using, so what is the cross sectional area? Pi r square. Right? Now you are in terms of diameter, r equal to d by 2 na, pi by 4 d square. Hope it's clear. Right? So what the term that you are having, dA by ds term. Right? In the last equation you will get the term as dA by ds. So how you can write it out? dA by ds. Right? So dA by ds. Right? So I just want to write out the equation if you required. So 1 by r, so dr by ds is equal to 1 by L dl by ds minus 1 by A dA by ds plus 1 by rho d rho by ds. So this is the equation. So in this I just want to vary the, in place of area, if area changes your diameter also changes now. That's why I need to convert it into diameter. Right? Why we are converting we'll discuss. Right? So if you write dA by ds, so then differentiation change pi by 4. So what is d square? 2d. Right? Pi d by 2 dd by ds. Right? Pi by 2 d into dd by ds. Right? So what you are having, 1 by A dA by ds. So for this we require 1 by A dA by ds. So then substitute here. So 1 by A, here pi d dt by ds by A means, so what is A? Pi by 4 d square. So pi d by 2. Right? So dd get cancelled, pi get cancelled. So what you are getting? 2 sir. So you'll get 2 by d, so dd by ds. So what is the value of 1 by A? dA by ds is equal to 1 by A dA by ds is equal to 2 by d dd by ds. Right? Then substitute 1 by A dA by ds in this equation. Then write out the whole equation. So 1 by r, so dr by ds is equal to 1 by L dl by ds minus 2 by d dd by ds plus 1 by rho d rho by ds. Right? I hope it's clear. So nothing is there. You replaced A in terms of D. So how you can calculate 1 by A dA by ds? You will get 2 by D dd by ds. Hope it's clear. Right? Now so dr by r is came, del r by r is came. So you can cancel this ds term, ds term, ds term, ds term. Right? So whatever the differentiation which is equal to small length na, small value na, so it can be denoted by delta. Right? Now write down the equation. So for a gauge factor, so what is a gauge factor? So del r by r by del L by L. So del R by R you find out. Then divided by del L by L. That's it. So I just want to write out the equation first. Del R by R is equal to del L by L minus 2 del D by D plus del rho by rho. For this gauge, if you want to find the gauge factor, again you divided by del L by L, then divided del L by L, then you will get this by del L by L, this by del L by L, this by del L by L, right? So then you will get the gauge factor is equal to, so del R by del L by L, we can call it as a gauge factor. So gauge factor is equal to 1 minus 2 del D by D by del L by L plus del rho by rho by del L by L, right? So first here if you want to know Poisson's ratio. So what is a Poisson's ratio? So the Poisson's ratio, it can be denoted by sigma gamma. So gamma is equal to minus del D by D by del L by L. So whatever the change in diameter by change in length. So that we can call it as a Poisson's ratio. Right? So then you substitute your Poisson's ratio here, you will get 1 in place of minus, right? Minus 2 na, it will goes to plus 2 gamma plus del rho by rho. You can make it as delta L by L. So simply you can take it as a small length that you consider, right? You can relieve this or else make it this one by delta L. Right? So now the overall gauge factor is equal to 1 plus 2 gamma plus delta rho by rho. What is delta L by L? We can call it as a strain. Strain is equal to delta L by L na. So then substitute strain. So there is the formula for gauge factor. Alright. So nothing we did, simply. So what are the factors that are changing delta R by A? First you have to differentiate. Right? So delta R by R kaval. First you have to differentiate with respect to stress. So after that 1 by R chesanu. After that what I did. So in terms of A, I have to calculate in terms of D for a Poisson's ratio. So for this, what is the dA 1 by A dA by ds? You got T by 2 by D dd by ds. Then substitute here. And then after that, if you want to find out that whole total term is divided by delta L by L, that is called strain. So then I divided the value by delta L by L. Then you will get the 1 minus 2 delta D by delta L by L plus delta rho by rho plus delta L by L. So whatever the Poisson's ratio, we can call it as a minus delta D by delta L by L. So this we can call it as a Poisson's ratio. That means change in diameter by change in length. So right. So then I will get the Poisson's ratio is equal to G. Gauge factor is equal to 1 plus 2 gamma plus delta rho by rho. If require L by delta L, or else delta L by L, we can call it as a strain. Then you apply a strain here. The whole formula is this thing. Alright. Now explain with this formula. So what is the gauge factor is equal to 1 plus 2 gamma plus delta rho by rho by strain. Right. So this factor, how the resistance change? This factor by changing the length of the conductor. So resistance right? So this factor shows the resistance change by changing what, the diameter or the area of the conductor. So this factor shows the resistance change by changing the resistivity of the material. Right? So whatever the gauge factor that you are finding means total how much changing the resistance in the strain gauge. The one term represents the changing the resistance by changing the length of the conductor. 2 gamma, these terms represent by changing the resistance by changing the diameter or cross sectional area of the conductor, and this we can consider as a resistivity effect. There is change in resistance by changing the resistivity of the conductor, right? So that's basically this effect we can call it as a piezoresistive effect. We discussed in the following session piezoelectric transducer, right? We can call it as a resistive effect. So basically we should neglect, in some other cases we should neglect this type of resistivity term. Basically this type of resistivity we can make that all the materials that you are having is equal resistivity. So that's why we need to neglect this type of resistivity. Then the gauge factor formula becomes 1 plus 2 gamma. If you neglect the resistivity, your gauge factor, so you can note it as 1 plus 2 gamma. So gamma is nothing but Poisson's ratio. So what is the Poisson's ratio? Minus dd by b by dl by l. Simple, right? Now we'll discuss how the gauge factor for different cases, right? See, gauge factor is equal to 1 plus 2 gamma. We neglecting the resistivity of the materials, right? So for a metals, so gamma value 0 to 0.5 for a metal. So if you use a metal, the gamma value will be 0 to 0.5. In that cases, your gauge factor is equal to 2 around, right? 1 to 2 or 1, right? If you go for any other metals, semiconductor materials, right? So basically you will take the gamma value will be 0.3, right? So if not given the gamma value, you have to take it as 0.3. For a metal, 0 to 0.5. So then here gauge factor will be 1 plus 2 into 0.3. So what is value? 1.6. Right? For a metal, basically gamma value will be 0 to 0.5. So if it's treated as this thing, the gauge factor is 1 or 2. For any other materials, if the gamma value is not given, then you have to take it as 0.3. So then the gauge factor is equal to 1.6. Right? So this is about the gauge factor and the strain gauge. Right? I hope it's clear. So what is a strain gauge? Strain gauge is nothing but when a metal conductor stretched or compressed, the resistance will change. So you have to find that resistance with the help of Wheatstone bridge. So you can find your strain value. So basically, if you want to measure a strain gauge, first you have to know gauge factor. So how the gauge factor it will deliver is that how the resistance will change. Resistance will change by changing the length of the conductor, by changing the cross-sectional area of the conductor, by changing the diameter of the conductor, by changing the resistivity of the conductor. right? So what is a gauge factor? Defines as a change in resistance by change in length. So gauge factor is equal to delta R by delta L by L. So if you want to measure the change in resistance in a strain gauge, you just want to find out the gauge factor itself. It will show all the contents, what are the things that are varying. Right? So how you can derive the gauge factor? So after that simplification, you will get the gauge factor is equal to 1 plus 2 gamma plus dou rho by epsilon. So epsilon we can call it as a strain. Right? So basically 1 denoted by a changing resistance by changing length of the conductor. 2 gamma represent the changing resistance by changing the diameter or the cross-sectional area of the conductor, and dou rho by rho, that means resistivity, by changing the resistivity. That effect we can call it as a piezoresistive effect. So basically some of the cases we need to neglect these piezoresistive effect. Right? So for metals we just see 1 plus 2 gamma is a ultimate equation for this. Right? For a metal, if you choose that the gamma value varies from 0 to 0.5, in that case its gauge factor is equal to 2 to 1. And some other cases the gauge factor, if not given, you have to take it as 0.3. In that cases the gauge factor is equal to 0.6, 1.6. Now we are going to discuss what are the different types of metals that are used in a strain gauge, and what its gauge factors also. So the metals are nickel, cadmium, next magnesium, constantine, platinum, carbon. Right? So these are the metals that we are going to use in a strain gauge, right? So nickel, cadmium, magnesium, constantine, platinum, carbon, right? These are the metals, right? Right. So these are the various metals that we are using in our strain gauges, and these are the gauge factors, right? So what are the metals? There are nickel, cadmium, magnesium, constantine, platinum, carbon, and doped crystals. So here the doped crystals which is having high sensitivity. If you use a doped crystal material which is having a high sensitivity, so that sensitivity value will be 100 to 5000. So this is a very gauge factor high. So nickel which is having minus 12.1, cadmium plus 2.1, magnesium 0.47, 2.1, platinum 1.8, carbon are having 20. So these are the various metals that are used in a strain gauges. So this is about total strain gauge concept. So in this what we discussed means what is the definition of a strain gauge, what is the working principle of a strain gauge that we discussed, what is the definition of stress, strain, right, what is the working principle, how the resistance will be changes, right, rho L by A. So what is a gauge factor, what is the definition of a gauge factor, and how to solve the equation for a gauge, we derive the equation for a gauge factor. And after that what is the value of mu value, with that we can easily define a gauge factor for the various metals. Alright, if not given Poisson's ratio, it will take it as a 0.3. After that we discussed about various metals that we are used in a strain gauges. Right, I hope it's clear about all the concept of strain gauge. Thank you for now.